Rahim. Inshallah, today I'm going to speak about high impedance restricted earth fault protection relay in power transformer. In this session, we'll see how the REF will protect the power transformer. If you check this small diagram of REF connection, we have here three phase with three phase CT. Assume the phase CT is 1000 by 1200 by 1 amp. Also in neutral CT, we have same ratio 1200 by 1 amp. In high impedance restricted earth fault protection relay, the CT ratio should be same, but in the low impedance, as you know, the REF protection relay, it can by two configuration or two scheme. It can come by low impedance or high impedance. In high impedance, the CT ratio should be same, but in the low impedance, the CT ratio it's not necessary to become same, because as in low impedance we have their CT matching factor. Okay. Now we can simply understand the REF work by give some study cases or some fault location in the diagram. Now assume I have fault R to air fault in this location. If you check in this location, this fault, it is external fault. So the REF should be what? Is not operate, right? Because I need REF only operate if the fault happen in zone. So what's mean in zone means the location between this phase CT and neutral CT. Any fault out of this CT, the REF should not operate and should be stable. Now assume we have external fault. Assume this fault, let's assume 4000 amp. Okay. So how the fault current path will be? The fault current will go like this. The fault current will go like this. Okay. Then will go like this up to this fault point. So what will happen here? This CT, R phase CT, he will see this fault. Also the neutral CT will see the fault. And as you know, the REF protection, it's worked simply by the Kirchhoff law. Sum of entering and outgoing current will be equal how? 0. So the in and out current will be what? Equal 0. So assume here 4000 amp. So the fault current will be like this. Okay, will go like this. And also from the neutral CT will go like this. So I have both current from phase CT and the neutral CT, but in opposite direction. So the in and out will be equal how much? 0. So REF protection relay will not operate. So assume now the fault current is 4000 amp. So let's convert this 4000 amp into the secondary current. So just we'll divide 4000 amp divided by CT ratio primary 1200, I think will equal 3.3 amp. So this 3.3 amp will go to the REF relay, and also as you see the neutral CT will see the fault. So also we have 3.3 amp current going to the relay, but in the opposite directional. So the relay will not operate because the 3.3 minus 3.3 will equal 0. And assume the pickup current here for this REF relay is 0.1 amp. So the differential current is equal 0. So the REF should not operate, and that's why. And this what we need actually, because during external fault we don't want the REF relay to operate. We need only the REF operate when the internal fault it's happened. Okay, so this is the case 1. If the fault external, should be the REF relay stable and should not operate. Now let's see the case 2. Case 2, assume now the fault in zone here. This is the fault of the location. So how the fault current will go? The fault current now will go from the low path resistance. So the fault current will go like this, then neutral CT, then like this up to the fault point. Okay, so the fault current will go to the neutral CT, then to the fault point. Okay, now let's see. This CT, he will see the fault? No, he will not see the fault, because the fault current is always seeking the low path resistance. So the low path resistance will go to the neutral CT, then up to where? The fault point. So the phase CT, he will not see the fault, only neutral CT will see the fault. So that time, this assume 3.3 amp will go to the RAF relay, then RAF relay will operate. Then RAF will operate, because we don't have any secondary current coming from phase CT. Because as you say, this fault, this CT will not able to see the fault. Only neutral CT will see the fault. Okay? Now this is the case too. When the internal fault, the phase CT will not see the fault, only the neutral CT will see the fault. So the RAF relay will trip or will energize. And that's what we want. During internal fault, the RAF relay should be operated. Now let's study the case 3, which very important case. Now assume the fault, external fault, okay? Same external fault. Now assume, as you say, this CT and this CT, he will see the fault. But assume now, because this high fault current, maybe this CT will be saturated. If this CT saturated, means there are no secondary current will go to the where? To the relay. So there will be no opposite current from the neutral CT. So assume the fault is happening here. This CT will see the fault, but assume this CT is saturated. Means if the CT is saturated, means the secondary current will be zero. So the current will be zero here. So only neutral CT will see the fault, also will see the fault, and 3.3 amp will go to the RAF relay. So the RAF relay will operate, die to where? CT saturation. So how to avoid this issue? So that's why in high impedance restricted air fault we'll connect series resistance. We call it stabilizer resistor. So how to avoid this issue? If one of the phase CTs gets saturated, just we connect stabilizer resistor series with the relay. So now assume the CT is saturated, means the neutral CT secondary current will go to the relay, but die to this high resistance, the current will not go to where? To the RF relay. So we'll force this fault current to go in this side, and the RF relay will not operate. Die to where? To the this high resistance or stabilizer resistor. Okay? So this the case 3. If you have external fault and one of the phase CT gets saturated, so we need to use the stabilizer resistor to avoid the mal-operation of RAF protection relay. Now let's see the case 4. What's very important also, assume now we have internal fault. As you say, if we have internal fault, okay, the RAF relay should be operated. Now assume I have internal fault, okay, and we have here high resistance. So if you have high fault current in zone, and we connect series resistor with the relay, means we have there big voltage. This big voltage can lead to damage the RF relay. That big voltage can lead to, or maybe will damage the RF relay, and RF relay is very expensive. So how to protect this relay? Just we connect non-linear resistor, we call MOV or metro cell resistor. We'll connect it parallel like this. We'll connect this MOV. We connect non-linear resistor. So this big voltage, what produced here, down to the internal fault, this MOV will bypass this big voltage to the ground. So the RAF relay will protect it. So the RAF relay will protect it. So this purpose we need RS, stabilizer resistor, and MOV in high impedance restricted air fault protection. I hope this session it is clear and you understand how the RAF will work and how high impedance scheme is work in RAF protection relay and power transformer. In next session, I will show you how to calculate stabilizer resistor and also how to calculate the MOV, stable MOV and stable value of stabilizer resistor. Okay. Also for the testing, we can test the high impedance by the secondary injection method like CMC or VIPCO or any test kit secondary injection. Then we'll go through primary injection. First we go through the secondary. We can use choose both. We can implement the voltage method or current method.